we'll move ahead to the regression. Okay, regression is way more easier than classification. Okay, you will see this. Okay, pretty simple, right? You remember the question that we had in the beginning, end-to-end project, the California housing data. I hope everybody is clear about the data set. Yes, that we had to predict the median housing pricing, and we had all these parameters that we wanted to do. So what we're going to do is we're going to feed that data as such. Okay, just that we are scaling it because it's going to be gradient descent. It's generally found that scaling the data is useful. So we loaded the data. Once we loaded the data, and notice this, sklearn dot datasets have a function called fetch this. Just like there was another function to load the previous data set of fashion MNIST, similarly, we have the California housing data. Now, we also actually use the same model, it's the same function that we used earlier, that splits the data into training and test set randomly. And then we are also using scikit-learn's function called standard scaler. Okay. Though we have similar functions in TensorFlow, but we still prefer the sklearn ones and scikit-learn ones. After loading it, we split it into training and test based on a fraction here. We are saying, I think by default it's 80-20 or something. Okay. Okay. Then we break the training full into training and validation. So we have now 3 sets of data: training, test, and validation. And now what we're doing is we are scaling training and test, training, validation, test data. You see that? We are only scaling the X, not Y. We are not scaling Y. We are only scaling X. Okay. Also, please notice that whatever parameters on which you want to scale, the max and min and so on, those parameters we are only learning from training. So if we are, how do we scale usually using standard scaler? You must be knowing. We calculate the standard deviation. For standard deviation, we calculate the mean and we subtract with the mean and we calculate this, right? Standard deviation by summing up all the values, and then we have standard deviation. Then what we do is we basically divide, subtract every number by mean, divide by standard value, right? X minus mean divided by standard deviation, right? How many standard deviation away is S from the mean? This is how we do that, right? So this is how we do the scaling. So the mean and standard deviation was only computed on X-train. And X-train was transformed using the same mean and standard deviation as we are doing X validation and test. Because there we are calling fit transform, here we are just calling fit. Okay, so that whatever operations we are applying on the training set, we only apply the same operation on the test and validation, right? So that the learning from the training is consistent with the test and validation. Question from Divya is, we don't need to do one-hot encoding for categorical values. Yes, we do. Just that we have ignored it here, but in reality, we need to do. So ideally, what you should do is you should do the one-hot encoding for those variables, categorical variables. Thank you, Divya. Very good question. A question from Santosh is that random state is 42, same as random seed. Yes, actually, that's right. That's right. And further to Divya's question regarding the categorical variable, here we are not taking care of those variables, right? What will happen? Our performance will be bad, okay? But we are okay for that time being. But in reality, you should actually do the one-hot encoding and other stuff, okay? Now, next is once we have defined these X-train and Y-train, okay, right now it's going to download this. It's downloading in my home directory and in this folder. Let it download. Is it done? Should I just check? Okay, let me just check if the data is there or not. Also, I'll just go over this neural network so that you have the full week to try it out. Now here, there is nothing much, right? We defined a model with this kind of a dense neural network, okay? And there is only one value in the last layer. Why? Because we are just predicting the median housing pricing, right? We don't have to worry about anything. And also here we are just doing the mean squared error. Also in SGD, you see that? Keras.optimize SGD, and we are passing this. I think learning underscore rate is what we have to specify. I don't think LR would work. And then we are saying fit, X train, Y train, epoch is 20, validation data. All of these we have discussed already. And then in the end, we are evaluating. Let's just see how it goes. Okay, so loss is going down. You can see the loss is going down. And then, right, now, after a point of time, the validation loss is going down slowly, not at that fast pace. Okay, so it is done. Now let's take a look at the learning rate. So you can see that the mean squared error went down like this. Okay, the mean squared error went down pretty well, and the prediction is this much. Okay, the predicted values is this much. And also you can compare this mean squared error with respect to the other models that we had tested earlier. Okay, so the loss in general will be very, very low. And you can see that this simple model would outperform many other models. Okay, this also notice the model.summary. Okay, model.summary. Okay, so today's session has been very successful. We did one classification example and we did one regression example, right? And the classification and regression are basically two ways to get started with the neural network. Okay. A question from, so that's pretty much for today. We will continue from here next week. Okay. So this is like, to get you started immediately. Now you can start solving many other problems, and we will walk towards improving the performance of the model as we go ahead in the remaining chapters. Okay. A question from Domenico is that, could you repeat why do we do fit transform on the train and only transform? Because if we are subtracting and dividing the training data with some 10, okay, so what it's going to do is, imagine, then it's going to do x minus 10 divided by 50, right? Fit as in learn from the data, figure out what is the mean value, what is the standard deviation in order to do the standard scaling, correct? So every number will be subtracted with 10 and divided by 50. If 10 is the mean and 50 is the standard deviation, that's what is standard scaler does, right? Now, if we are subtracting something with this number and dividing with this, right? If we are doing that for the training set, it'll be unfair to the model if we use another such numbers to translate our data. Therefore, if we are translating training set with whatever function, we should also translate the testing set or validation set, or even in production, you will have to use the same values for translating data. Okay, remember this, that in the scalar, you should, right? It's a very important question. Lots of people will say that when they go take this model, we prepared the neural network and we shipped that model. We will forget about this model because this model is also doing some transformation. Okay, so when you are moving your data to production, do not forget about this. You have to do this on your production data as well. And that time you don't have to do fit transform. You just have to do transform. Otherwise, your model will not perform great. Great question. All right. Wonderful. So a question from Nitin is, what is this here, right? There I use some kind of here, I think, yeah. LR equals 1E. This is essentially, what is this? This is essentially 0.001. That's the learning rate. That's how you write it. Okay? In the exponent, in Python, you can do that. Question from Manoj is, why did we not use RMSE in regression? Okay, good question. My question to you is, if our model is minimizing mean squared error or square root of it, is it the same thing or is it not a different thing? If something's mean error is lesser, its square root is going to be lesser, correct? Therefore, whether we use root mean square error or mean square error, it's the same thing. What we did was by using mean squared error is that we reduce the computation. Square root is a very aggressive computation. Okay, not very aggressive, but yes, it takes decent amount of computation. So you should actually try to compute the square root without using any mathematical library. You'll know the meaning of square root. Okay, good question, very good question. So we are using mean squared error because computing root is difficult, and mean squared error does exactly what root mean squared supposed to do. Wonderful. And few more questions, and that'll be it. I won't be taking anything else further. Let me just clear everything. Okay, these questions I'll just finish, and then question from Vaishnav is, so when using deep learning for regression on the California dataset, we did not have to do all those data preparation activities to get to create model. Ideally, we should follow that, Vaishnav. Ideally, we should follow that. But since we wanted to demonstrate how to do things using Keras, we took shortcut. Okay. Ideally, you should follow that process of end-to-end project. That's a very valuable, and I think Divya also pointed out that part. So yes, those two, I mean, you should not skip that process. Or feature engineering, you can skip to some extent, but the other parts you should like categorical sampling, right? And so on. So those things you should not miss, and you should actually follow that process. Question is from Puneet. Would a neural network make sense in solving problems such as California housing pricing, as eventually we don't have any coefficients to determine the relationship between prices and independent variable? How will someone make a strategy based on neural network result from that? Good question. And if somebody asks you in the interview, you always say that it depends on, and I mean, this is very interesting question for an interview. You always say that see, the neural network will not be able to tell you exactly how it's thinking, though it'll be able to give you better results. So if you are looking for interpretation, probably a simpler model like linear regression or a decision tree would make more sense. But if you're looking for better results, I would say that go for neural networks. Great. And question from Aaron is that wouldn't min-max scalar be better here instead of standard scalar for regression problems? Good question, Aaron. It has been found that when we do the standard scaling in neural network, it gives better results. It gives way better results, and as compared to the min-max scalar. All right. Okay. A question from Manoj is, when we get high value for mean squared error, then we probably look for RMSE. Actually, since it's a loss, we don't care if it is high or low, right? So it doesn't matter to us, because while we are testing whatever error we get, we will compute the root mean square error at that point of time. maybe you can use RMSE or other matrices for observing your, how is your model performing. But since remember that loss function, in case of backpropagation, we calculate loss and then we change the rate of change of loss with respect to each of the gradient. If you think about it, so many times the loss will be calculated, and therefore, and rate of change of loss will also be calculated, and rate of change of loss is even further harder. You remember that root of x is how much? 1 by twice of root x, right? And then again, we have to not only do the square root, but also do this. So usually it has been found that for performance reasons, we just go with that. In case you're looking for better matrices, use those as matrices here. When you do fit, okay, you do the specify the matrices which you're looking for. Okay. Well, yes. So root mean square error, you can do it in the validation side. That's question from Venkat is that please show the way to download the content of this notebook. You can just do git pull. I'll be committing this notebook. Okay. There'll be a lot of junk in this. Whatever I typed, so please ignore that part. And I think I've deleted some of it already, but I think you will be able to figure out. So I'll just commit this right away. Okay. And you can just clone it or download it from the GitHub because it's public. Okay. And my strong recommendation is always use the Git in order to download, because before committing, you can always synchronize. And if you want to further contribute to these notebooks, you can fork it and then clone it and then keep committing to your own directory. And whenever needed, you can reintegrate with our repository. Just go through Git tutorial. You'll get an idea how to handle the Git. Okay. So all kinds of complex things can be done in using Git. That's why I always prefer it that way. I'll just commit it right from the changes in the class. Okay. I hope I'll not make it really ugly. I'll just push it. Okay. All right. A question from Puneet is that just to confirm the accuracy we calculated during each epoch in the classification is accuracy correctly predicted. Yes, that's right. So you can actually specify their precision and it'll basically do a good job. Okay. So try putting in the matrices here, in the matrices wherever you are doing the work, there try to do the unknown function precision. Is it? How about F1? No? Okay. Matrices for model dot. So there is it'll show you all the so there is AUC, accuracy, and hinge loss. Okay, if you are planning to use a hinge loss, that is SVM loss, in that case, you can use this instead of mean squared error or some other classification. In classification, you can use that. Precision, did I make a mistake in this? Okay. What if I just put it like this? Will it work? Okay, it says okay, we'll have to see why it's throwing an error. Okay, so I'll take a look at it, like how to call it using precision, but you can definitely pass a precision, or you can also pass here. I think the problem is with respect to the loss function. If it was straight cross entropy, it would have been easier to just apply the precision. Okay, and that's one of the reasons. All right, great. A question from RMSC pushes larger error that might be there because of outliers. Yes. Yes. So RMSE and MSE have the same behavior when it comes to computing the loss. And wonderful. So great set of questions. And all right, I look forward to see you in the next session.